Good afternoon, everyone. Welcome to this episode. We'll be talking about classification of what differential equation. Now we have five classification of differential equation. We have by order, number one, by order. Under that, we have the first order, we have the second order, we have the nth order. Number two, we have by linearity, we have the linear, and we have the non-linear differential equation. Number three, by homogeneous. Under that, we have the word linear D. Number four, by type or form. Now, these are the word five, four classification of what differential equation. Now, but we're going to be starting with the first order. That is the first order differential equation. Now, under this first order differential equation, it is further classified into two. The first one is the word linear differential equation, while the second one is the word non-linear differential equation. Now, before I proceed, let me explain the first order. That's why you have to watch the previous video I posted. It's very important so that you can get it for better understanding. Now, what do you mean by first order? First order is what highest derivative of coefficient. Now we have the y over the s. If they give you something like this without any value, any number here, definitely there's an invisible one. That's the what first order. So if you have the y over the s, if you have two here, we have two here. This one is the what second order. Do we get it? Now that's about, but we are dealing with this, the first order. That's what first order. What of linear? Linear is what must be raised to the power of one. Now we have the y over the s. This is the first order. We have it to the power one here. That's the what linear. Anything that is above one, maybe two or three or four, it was non-linear. Do we get it? I've explained all this in my previous episode. Go and watch it. Watch it from beginning to the end. You will get everything. Now let's start with the linear differential equation. Linear differential equation. We have one method of solving this. That's what integrating factor. We have the what integrating factor, which is the what if. While the second one, non-linear differential equation. We have five methods. Yes, we have five methods of solving any question under first order non-linear differential equation. Five methods. What are the five methods? Number one, we have the separable method. Number two, we have the exact equation method. Number three, we have the unexact to exact equation method. Number four, we have the homogeneous method. Number five, we have the Bernoulli method. So these are the five methods we have under non-linear differential equation. But for this episode, I'll be taking only linear differential equation, and I'll solve one example under it. So in our next episode, I'll solve more example under this, and I'll also go into the non-linear differential equation and solve using different methods that we have there. Now let's start with the first one, the linear differential equation. Now we're starting with what? The first order linear differential equation. The first order linear differential equation. Now, under this, we have one method of solving this. Only one method, which is the what? Integrating factor. Integrating factor. Now, the integrating factor. Now, how will you know? It must be in the general form. The general form of this first order linear differential equation is the general form is the y over the x plus p of x of y equals to q of x. Yes, that's the form. It must be in that form. When we solve example, you'll be getting it. Now, the integrating factor, formula for integrating factor, that's the integrating factor formula is if equals to what? Exponential integral p of x dx. You have to note that. That is the formula of what? Integrating factor. Do we get it? Now, let's solve one example. Example 1, we have the y over the x plus 2x equals to 4x. Now, let me explain something. If you are looking at this, if you are looking at this place does not mean that you must have 2xy here or 5xy. No, it must have a coefficient of y. It's not necessary if you have 2xy. Do you get what I'm trying to say? So, I draft out some steps to guide us on how to solve this using the integrating factor so that we will not be confused. Because if I'm to just solve it like that, right then we'll be dropping step by step. Step one. Step one, identify P of x and Q of x. Identify P of x and Q of x. Now our P of x equals to what? If you match them together, you see that there is of the form. Now our P of x equals to 2, our Q of x equals to 4. Do we get it? Step 2. Step 2, find the integrating factor. What is the integrating factor? The formula is if equals to exponential rate to the power of integral p of x dx. That equals to exponential integral. What is our p of x? 2 dx. That equals to exponential. You bring out the constant 2 integral dx. We all know that integral cancel differential. That equals to what? Exponential 2x. That's it. Because if this cancel this, we're having 2x. That's how we get this. So the next step is step 3. Let me check. Step 3. Step 3. Step 3 is what? Multiply the entire equation. Multiply the entire equation with the integrating factor. Step 3. Multiply the entire equation with the integrating factor. Multiply the entire equation with the integrating factor. Now, what is the equation? This is the equation here. So we are multiplying the entire equation with the integrating factor. Now, what is the equation? The y over the x plus 2 of x equals to 4x. So you are multiplying 2 with this. So we have um, the y over the x. Look, we have exponential 2x dy over dx plus 2x exponential 2x equals to 4x exponential 2x. You can see that we've already used the integrating factor to multiply the entire equation. Do you get it? Now, that's that. Step 4. Step 4 is that write the left hand side as the derivative of the integrating factor multiplied by y. Write the left hand side as the derivative of the integrating factor multiplied by y. That's what they mean by that. Now let me write it for you. We have exponential 2x dy over dx plus 2x exponential 2x equal to 4x exponential 2x. What this one is trying to say is that you should what? This is the left hand side, this is the right hand side, because if you to solve the left hand side using the product rule, it will still give us this. So to confuse us, just write the left hand side as the derivative d over dx of what? Integrating factor times y. Don't just write if because we have solved for the integrating factor in step 2. Now what is the answer for the integrating factor? Exponential 2x. Exponential 2x multiplied by what? Y equals to what? 4x exponential 2x. Hope you are following. So that's about that. Step 5, integrate both sides. Step 5 says that what? Integrate both sides. So you have integral d over dx exponential 2x dot y equals to what? Integral of 4x exponential 2x. We all know that differential will cancel integral. So we have what? Exponential 2xy equals to what? Integral of what? 4x exponential 2x. Do we get it? Do we get it? So we are still solving, we are not done yet. We have exponential 2x y equals to integral of 4x exponential 2x. Now look at this. We want to integrate this one here. How are we going to integrate it? Definitely this is what? Integration by part. Integration by part. There are some questions that you will see that what you will have to do there is what? Integration by substitution. There are some like that. There are some integration by part and this. But how are we going to solve integration by part? There's what we call liet. Liaet. L there is what? Logarithm. I is what? Inverse trigonometry. A is what? Algebraic. E is what? Exponential. T is what? Trigonometry. The logarithm means the log and the lane and so on. The I means the inverse trigonometry where we have the what? Sine inverse, tan inverse and so on. The A means the algebraic. What do you mean that algebraic? Our x, y or z. E is the exponential. This. While our t is the trigonometry, our sine and tan. Know the difference between sine and sine inverse. Now, how are we going to know our u? How are we going to know our v in this place? Now, this liet here, what comes first in this liet will be our u in our given equation. As we have log here, definitely our log will be our u because it comes first here. But if you look at it, algebraic is the first thing that appear in this place. So therefore, our u will be what? 4x. Now, what is the formula for integration by part? The formula is what? Integral u dv is equal to what? Uv minus integral v du. This is the formula. So what we do our u? Algebraic come first here. So and there's algebraic here. So our u is our what? 4x. U equal to 4x. But if you look at it, integral 4x exponential 2x. And we have this to be what? Integral u dv. Once we've gotten our u, the next thing to get is what? The v, not v. So once we get the v, we are now going to get our v. Do we get it? Yes. So if our u equal to 4x, the u over dx, differentiating u with respect to x, we are having 4. Then the v equal to what? Exponential 2x. Now, we have the v. So, we want to get our v. So, we have to what? Integrate so that our integration can cancel the differentiation. So, you integrate the v equal to integral exponential 2x. Differentiation cancel integral. V is equal to now. If you want to integrate exponential 2x, there's a short method. We have exponential 2x. You what? Divide by the coefficient of x. What is the coefficient of x here? 2. Divide by 2. That's the answer. Our v is what? Exponential 2x all over 2. But if they ask you to differentiate exponential 2x, just what is the coefficient of this x? 2. 2 multiplied by, put your question back, exponential 2x. That's for what? Differentiation. That's the short way of solving it. Now, let's put them into our question. In this integration by parts, forget the left hand side formula. Let's focus on the what? Right hand side formula. So we have what our u 4x multiplied by what is the v exponential 2x over 2 minus integral what is our v, this exponential 2x over 2 times. Now we have to make the u subject of formula because of this, because we have to put the value of the u inside this. So you got multiply the u equal to what? 4 dx. So what is the u? 4 dx multiplied by 4 dx. 2 here 1, 2 here 2. We have 2x exponential 2x minus integral is also the same thing as what? Exponential 2x multiplied by 1 over 2, because exponential 2x times 1 over 2, exponential 2x times 1, exponential 2x over 2. So it's still the same thing. So we have exponential 2x multiplied by 1 over 2 times this 4, and we have dx. So therefore 2 here 1, 2 here 2. So we have 2x exponential 2x minus 2 times exponential 2x was integral 2 exponential 2x dx. Now we have was 2x exponential 2x minus, now this your constant to come from if you are integrating 2 integral exponential 2x dx. So we have 2x exponential 2x minus 2. I told you if you are integrating exponential 2x, what is the coefficient of s? That's exponential 2x divided by the coefficient of s, 2. So that's what we have already started integrating. So once you start integrating, don't need for you to put the integral sign. Just multiply like that. Exponential 2x over 2 plus your what? Constant. Now 2 here 1, 2 here 1. So we are having what? So we are having what? 2x exponential 2x minus exponential 2x plus c. Now don't forget that this is what we solved for just now. So we are putting it back. So we have exponential 2xy equals to, when we solve for this, what do we get as our answer? This is here. 2x exponential 2x minus exponential 2x plus c. Now the next step, according to what I've been giving you, was step 6. Step 6 is what? Make y the subject of the formula. Now we have this exponential 2xy equals to 2x exponential 2x minus exponential 2x plus c. So if you are to make y the subject of formula, we have to divide everything all through by the coefficient of y. What is the coefficient of y here? Exponential 2x. Divide both sides by exponential 2x by what? Exponential 2x by what? Exponential 2x by what? Exponential 2x. Exponential 2x cancel this. Exponential 2x cancel this. This cancel this. So we are left with what? Y equal to what? 2x minus 1 plus c over exponential 2x. Now we have our y equals to 2x minus 1 plus law of indices. If we want to make our denominator to go and make the numerator, the division there will not be part. Yes or yes? So we have c exponential raised to the power of what? Because of this part, it was minus what? 2x. So with what we have been solving from the beginning, this is our what? Our final answer. And do you also know that this is also the what? General solution, because of what we have what? Arbitrary constant, this letter c. If they now give us, find the particular solution of this, if they give, they will surely give us a value, maybe 1 or 2. We all know that this place is x and y. So wherever we see x, we are putting 1. Wherever we see y, we are putting 2 in this equation. If they ask us to find a particular solution, and they can also give us the in exam, or give us an exam that we to solve this question that we just solve now and find the general solution. Don't stress yourself, this is just the general solution. Don't go and start solving again. Do you get it? So this is where I want to stop for this episode. In our next episode, we'll be treating more examples, and we will go into the what non-linear differential equation using the what five method I told us about earlier. I believe that you learned something from this episode. Don't forget to what like and subscribe. Thank you.